so now we're going to be given a composite transformation on a graph, and we are going to need to determine what happened in proper notation between the pre-image and the image. Now for numbers 1 and 2, it's kind of guided for you. For example, in number 1, you can see that we took triangle ABC and we first reflected it over the x-axis, and then it looks like we translated it because there was no turn that happened. If I look from B prime to B double prime, it looks like I translated it over 1, 2, 3, 4, 5, 6 units to the right and 2 units up. So now we're going to write this in proper notation. The translation happens second, but it's actually going to be what you write first. So the translation of 6 units to the right and 2 units up would look like this. And then we do an open dot for the composite transformation. And our first transformation was a reflection over the x-axis. And we went from pre-image, triangle ABC, to get triangle A double prime, B double prime, C double prime. Number 2 is guided as well. So what happened between triangle ABC and triangle A prime, B prime, C prime, which is this one right here, what looks like what happened is we did a 90-degree turn, rotation about the origin. And a way that you can determine this is if I look at point B, which is at point 2, 4, and I look at point B prime, which is at the point -4, 2, it helps knowing my mapping rules, because if I take my pre-image point, my pre-image y value, make it negative, and then flip-flop x and y, I do get my B prime values, and that was a 90-degree rotation about the origin. So that was the first transformation. And then a reflection must have happened over the x-axis, because we can see that A prime is 1 unit away from the x-axis and A double prime is 1 unit away on the other side. So we're going to write that now in proper notation. The reflection happens second, but we're going to write that first in our composite proper notation. And then the rotation of around the origin 90 degrees happened next. Now, sometimes you will not be guided to what happened between your image and your pre-image. For example, number 3, you're not guided. It says describe a sequence of transformations that map the pre-image onto the image, and then write the rule in proper notation. Now for this, you just got to kind of play around with it. There are many different ways that you can get from triangle CAT to triangle A prime, T prime, but you just gotta kind of play with it. So if I translated C 5 units to the right, that would put C directly underneath C prime. And if I reflected that C over the x-axis, that would put me right on top of C prime. So let's see if it works for my other values. If I translate A 5 units to the right and reflect it over my x-axis, that puts me directly onto A prime. And then I need to check T as well. If I translate T 5 units to the right and reflect it over the x-axis, that puts me right onto T prime. So that would be an example of a transformation that would work. So I would say first was the translation and then the reflection. So I first state the reflection first. And then I'd state my translation. Now, when you're doing these problems, it actually might be useful for you to test to see if any rotation occurred, because I believe rotations are a little bit tougher than reflections and translations. And for me, I could tell that a rotation did not happen around the origin, because getting C to C prime, even if it was a 90-degree rotation around the origin, C would be up here. Or sorry, 270 degrees, C would be up there. So I could tell that it wasn't a rotation, but you might not be able to. So it might be easier for you to start with a 90-degree or 270-degree or 180-degree rotation first, just to check to see if a rotation was involved. And then you can start working on reflections and translations to try to get the triangles to match up. That might be a good idea, just because rotations are the toughest ones to figure out. So number 4 and 5, now we are going to use all the isometric transformations. So we're going to use reflections, rotations, and translations to map the points onto each other. Now there's many different ways that you can do this. For example, for this one here, I could do, let's see, if I did a rotation of 180 degrees about the origin, that would put point A here. Then I could do a translation up, 1, 2, 3, 4, 5, 6, which would put A here. And then I could do a rotation or a reflection, because that's the last one that I need, around the line x is equal to 1.5. which would bring A on top of A prime. So that's one way that I can get it. I started with my rotation because it's the more difficult one to do, but you don't have to start with the rotation. But I used all of my isometric transformations, which is what they want. And they want you to write it in proper notation. So my last one that I did was a reflection over the line x is equal to 1.5. My second transformation was the translation of 6 units up. And my first transformation was the rotation about the origin 180 degrees. And that took A, and it's not A triple prime, I just labeled it as A prime, that's fine. Next one, so same thing, let's try to start with a rotation of 180 degrees about the origin. So when I do that, and you could do a 90-degree rotation if you would. Well, on this one you wouldn't want to, because you want them to stay parallel. If we did a 90-degree rotation, this would change the segment to look more like that instead. So this one we want a 180-degree rotation. A 180-degree rotation would put A here and B here. So this is what your segment would look like. So then there's many different ways that you can go about this. This is a tough one because we need A to map onto A prime. So what if we did a translation 2 units to the right and down 2? That would put A here, and 2 units to the right and down 2 for B would put B here. But again, I need A to map onto A prime and B to map onto B prime. So now I'm just going to do a reflection down the middle of that segment A prime B prime. So that would be something that looks like this. So that line actually has a slope of down 1 and over -1, so -1, and a y-intercept of -1. So I would do a reflection over the line y is equal to -x - 1. So that was my last my last transformation, doing a reflection over y is equal to negative x minus 1. My middle transformation was doing a translation over 2 to the right and down 2. And my rotation was 180 degrees about the origin. And I did segment AB to map onto segment A prime, B prime. And again, there were many ways that you can get here to here. These are just one example of each. But that's the end of that lesson.